All right, hey, really quick reminder, if I were y'all, I would be borrowing a calculator each night, take it home. If you could, leave the hat to it on my desk if you take one home. But I would be borrowing a calculator pretty much from here on out, because you're gonna need it.
Are we gonna log in?
Then
why does the login thing start on the thing?
Let me find a nicer calculator.
Or settings?
I just forgot to take that away.
Can you grab me a hat?
No.
That's 2.2, not 2.3.
Oh my gosh, you're wearing a different hoodie.
Jaden,
Use your ring.
you'd be taking up like half of the
Alright.
camera. Wait, hold on.
Brandon, you know you can sit anywhere you want, right?
Yeah? But there's,
He wants to sit in the normal groups. All right.
there's already 3 people on
You can sit anywhere.
Gotcha. So 3 and 4. Did we need to talk about these at all? We good?
Wait.
I don't.
You haven't even done 4.
Yeah, I haven't done 4 yet.
Whatever.
So-
Samaya.
Basic.
Whatever. Speak to that.
Oh.
Real quick note, don't forget, when you're dealing with these normal distributions, what do I always recommend that you do first?
Make a table, chart, whatever.
I would
graph.
graph, right? By the way, what's that graph called when you have that smooth curve like that?
Normal distribution, bell curve.
But it's called a density curve, right? So remember, yes, it's approximately normal distribution, but it is a density curve. And so what's the 3 numbers that we've got to know, Sanaya, for normal distributions? And that's one close to being one of them. Okay, so you need to study this normal distribution empirical rule. But we talked about it yesterday, okay?
68.
68, 95,
99.
and 99.7, okay.
Why does it have to be 99.7?
Because that's what it is.
Okay, but like.
We're actually going to learn more about that today, like all joking aside. That is what it is, and we're going to learn more about it today. Are those right? That feels off.
It looks right.
Okay. Right. So, do notice, we talked about this yesterday, there's multiple ways to do this. I'm just going to quickly recap this. There's multiple ways to do this, but what's the method I recommended to find this percent right here?
Did you do like nice?
Say that one more time. What were you saying? Okay, but do remember, we don't want all of that, so we gotta figure out how to get rid of this, right? So you can do that method.
Oh, right. Okay. Half it classic from that. 68.
Okay, so half it. So 1/2 will be 47.5. I'm gonna take 68 from that. Okay, so I'm gonna point this out. 95. Now, if I want to take out 68, not halving yet, but if I want to take out that 68, that's going to give me these 2 sides here. And then I could divide that whole thing. What just happened? But dividing that by 2 would tell me that that's 13.5%. So 13.5% is here, 13.5 is here, 68 is here, so I could add those 2 together now.
Yeah.
That's a way to do it. It's not the way I recommend though. There's an easier way.
But that makes more sense.
So remember, from -2 to 2 is 95%, right?
Be careful, use my teeth.
So what is -2 to 0? If -2 to 2 is 95%. Right, so this half right here is just 47.5, half of 95, right? So if I remember I said this yesterday, I like to play a game of halves, so I only have half of the 95 right here. And this would be half of the what? 68, so 34. So when I add those together, I get 81.5%. So I know I have half of the 95 here, half of the 68 here, there's my 34%, or my 81.5%. So that's how I always tackle those things. I used to do it that way that you're talking about, Lana, and then I realized this game of halves is just an easier game to play.
Do you do that?
Hmm.
Oh, those computer.
What?
Do you do Game of Halves?
What's that mean?
Offering Game of Thrones?
Really quickly, don't forget, this is about to come back up, percentile, what do we mean by a percentile?
If you're 1, 0,
Like
whatever.
So the percent at or below, right? So when I say 16th percentile, is this gonna be a value that's above the mean or below the mean?
At and
Wait,
below.
you said 16.
16th percentile here for number 4.
Oh.
Is that gonna be at or below the mean?
Below.
It's gonna be below the mean. How many standard deviations below the mean is that gonna be?
3.
What?
Oh,
Are you looking at
16.
16th percentile?
My bad.
Oh.
Let's count.
I don't wanna count.
Wait, let me cook.
Like 2. So you just keep going. Or if you wanna minus 2.
1 second.
Just wrap it up.
Okay, let me point this out. If I go right here to this point, right? Because y'all are saying 2, thinking 2 below. Then what part of the empirical rule should we be thinking about?
Minus 9.7.
If I'm looking here at 25.9, what part of the empirical rule should I be thinking about?
Oh, 95.
95, right? Okay. Now that's only the whole thing, so I'm only looking at the left half, so I'm going to divide that by 2, which gives me 47.5. So how much is in this tail right here? 2.5%, which means it would be the 2nd percentile. So I'm not looking at 2 standard deviations below the mean.
I'm at 1.
If I look at 1 standard deviation below the mean, what number are we looking at now? 68. Divided by 2 is 34. And so that's this portion. What's 50 minus 34?
16.
16.
Oh my god.
So the 16th percentile is
Right here.
28.6.
Oh!
So remember, the 16th percentile means it's 16% are at that value or less. It's definitely not going to be 2 standard deviations, which only has 2.5% below, right? 16th percentile, which I'm going to teach you a different method today that takes a little bit more time but will always work. The whole idea of the empirical rule is quick. It's not a get off power schools or whatever that is so you can focus on your learning. Thank you. Huh?
Don't do another one like that.
We're about to look at some more like this. Okay? Now, I will say this. We're not normally going to do a whole lot with percentiles and the empirical rule because there's only a couple of clean percentiles with the empirical rule. 16th percentile.
So things divisible by like 68.
Say again.
Never mind.
Well, like if you're using the 95 or the 99.7, that's not going to give you clear percentiles.
Fit 5, right?
Well, if you do the 5, but remember, it's only going to be 2.5%. So you could really say that's the 2nd, or, yeah, you can't say 3rd percentile, you'd have to say 2nd
Jade.
percentile. You good, Jade?
So creepy.
I know, right? But that's what I was saying, like, only the 1 standard deviation can give you clear percentiles, but we're going to learn a different method today. The bigger idea is using that empirical rule for finding different things. Okay, but again, not using the empirical rule a ton, but 28.6. If you have not done if you need more practice with the empirical rule, let me know and I can print some out. We're just not doing that right now. Okay.
Yeah.
Oh, it's not on. I haven't had to use it all day today. Alright, so we're going to be looking at normal distribution and locations in those distributions just in general, not just normal, through this mathematics set of lessons. So what we're doing is we're taking up with the cumulative relative frequency graph that I asked you to do yesterday, but go ahead and get out a couple of those mathematic lessons because we're about to get them. Yes, ma'am.
Where's mathematics?
Oh. You gave that stack of paper desk.
Oh.
So I just said updated.
Baker should be coming from trouble here.
Right over there for me. Alright,
Stop it.
Oh my god, we got so much diversity in this table.
so we are talking about cumulative relative frequency today. And then we're gonna get into, well, we're gonna get more heavily into the idea of calculating percentile. But, what do I mean by percentile, Braden? What do I mean by percentile?
Like, where that point is compared to everything at its point or below it.
So the percent of data that is at that value or below it, right? So it's percent at or below. Again, you may see some places where they define it as just what's below it. For the AP course and exam description though, it's at or below. Just like even though some places have 3 standard deviations, the AP exam says 2 for the outliers. All right. So frequency, so how many data points do we have between 56 and 60? Because I know you all did that last night.
1,
1, 61 to 65,
4,
and 66 to 70,
11,
71 to 75,
3,
and 76 to 80.
Uno.
Okay, so then what is the relative frequency? How are we finding that relative frequency for each of these categories?
Divide by
Just
11.
divide by 20, right? Like that's the relative frequency. So 1 divided by 20 is 0.05, then 0.2, 0.55, is that right? 0.15, and 0.05. So, let me ask this question, because if you understand, again, the language, it's something I'm always trying to push. Sanaya, what does that word cumulative make you think of? The whole, so can someone build on that a little bit more? Because yes, say again? Yes, by the end, right? But like, are we going to have all the information at the beginning? So what does it mean to accumulate something? That's kind of what I think of.
thus far.
It's what you have so far, right? When you accumulate, you keep gathering and gathering and gathering. So when I start here at the beginning, how much do I have in total? What's the cumulative amount by the end of this group? But remember, it's relative frequency. So what's the
0.05.
So cumulatively, I have 0.05. At the end of 65 inches, what's my cumulative relative frequency?
0.7.
5%.
Wait, yeah. I don't know how to count.
How do we get
Oh, you
0.25?
add them up.
You're just-
Oh, okay.
You're accumulating. That's it.
Oh, wait, this makes sense.
I understand
Yeah.
it.
Wait, that makes
So
sense now.
you had 0.0. So like really, what you had was 0 at 56. By the end of this grouping, you have 0.05. By the end of this grouping, you add that 0.2 to it, so you get 0.25. So what's the next cumulative relative frequency going to be? 0.8. We're just adding that 0.55 to it. So what's the next cumulative relative frequency?
0.95.
0.95.
100.
And then
100.
100. But now remember, they are doing this as percents, aren't they? So 5%.
What the crap?
Unbelievable.
So you can do it as a percent or as a decimal.
I don't want to say anything because
Thank you very much.
What was that?
Someone delivering
Did I ask?
excuses for advisory. Okay, so this would actually be 25%, 80%, 95%, and then finally 1 or 100%. Now, I do want to point this out. If you have a cumulative relative frequency graph, what should you always end at?
100.
Because you should, by the end, have all the data, right? You should have everything. Cumulative relative frequencies. I don't think they use this term on the AP exam anymore, but sometimes you'll hear them called ogives, O-G-I-V-E-S. That is an old term for it. Just be aware if you hear ogive, it's just cumulative relative frequency.
what does that even mean?
Yeah, what does
It means cumulative relative frequency
Ogive?
graph.
that?
I'm just telling you the term is ogives, O-G-I-V-E-S.
Should pick the better.
What does it mean?
So far.
I don't know the definition of it other than if you have, well, an ogive is a cumulative relative frequency graph. That's all I know.
Maybe some guy named Ogive discovered it.
And we're just like taking.
So, how am I gonna graph this? By the way, I do want y'all to notice, do we have our tools here on number 4?
No title.
No title.
No title, but do we have units?
Yeah.
Yes. Do we have labels?
Yeah.
Yes. Do we have a scale?
Yes.
Yeah.
Yes.
Wait,
Okay.
there's no inches or anything, so is that
This
really
is
units?
height in inches.
Oh,
The
I
paper's
thought
right
y'all were
in front of
talking
you.
about the
The paper's right in front of
table.
you.
No, the graph.
Oh, the crap.
Yeah, okay.
Oh my God.
So, I will point this out. We don't have the 5% until the end of this group, right?
Uh-huh.
So where's that 5% gonna go?
5 to 55 is, I mean 56 to 60.
Yeah, but like so like it's not gonna be
Put
a
it on the
point.
60.
Yeah, I'll put it.
So it's only gonna be a point at 60 at 5%. Okay, I'm gonna explain how to get to the rest of this in a second, but it's just a point at 5% at that height of 60. Okay? And so, where's this 25% gonna go?
At 65.
At 65 inches, so jumping up to 25%. There we go. That looks a little high. Really doesn't matter a ton. Alright, at 70, what am I gonna mark? 80%. Alright.
No, I mean like there's no.
The scale.
There's no.
What's next?
There's no like swing.
95.
95% at 75.
He was talking about
And 100% at 80. Alright. So, you know what I do with those points? Any guesses?
Connect them.
I connect them with a
Line.
line. Okay. So not a curve, we connect them with lines.
What's that one look like? It looks like a fruit 3.
That's the ugliest line I've ever seen.
Oh.
You're a what?
I'm not talking about the
People
I'm
are
talking about the actual line.
No, this
So
is-
that's not a line though.
Well, yeah, but you said line.
No. You connect the points with a line segment. I should be
Okay.
clear about
You
that
said
detail.
line.
So what's that?
Okay.
I'm 80 inches tall.
That's a cumulative relative frequency graph. That's it. Now, I will point this out. We had to end at 100%. What should we be starting at? 0%. Where would I put that 0% though?
Just look like at 55, because it's anything
I
up to
wouldn't do
55.
55.
At
At 60?
like
Not at 60. That was 5%.
It's just
I guess
straight
at the origin.
Yeah, that's
No,
fine.
but that's not.
That would be 0.
What have we done?
Bro, what?
Why above 55?
Oh, because 56.
Oh, this is BS.
Oh, because there's none at 50.
Because there's one at 56.
Well, what was the beginning bin? Or beginning of the first bin? 56.
So
Right.
right. Being
The beginning of that bin was 56.
Okay.
Okay?
Okay, but like, what if we get a midget in the class?
Well, we didn't have that data.
Size.
So, there's our cumulative relative frequency graph. So, what I want you to do is I want you to just go ahead and take a couple minutes, talk with each other. Use your graph here to do A and B. So I want you to talk with your small group. Use that graph that we just created. I was in the, yes, A and B right next to the graph. There you go.
66 inches tall. Estimate and interpret. Does that estimate?
I'm guesstimating.
So like, are we adding more in or is she already?
It's probably around like 40%.
I would
Neither.
say 30.
She is this tall.
like 50.
Use your graph.
Can we just
Estimate and interpret her cumulative
Like what
relative
closest
frequency.
house is it?
You remember, do it by 20.
Oh, that might be a good thought.
Oh, she's 66? No.
So 66, that's.
Also like.
Right, is that 4?
No, she isn't
6,
66.
11.
Okay, 45, I'll set it on 45.
Okay.
Going once, going twice, so it's a meter.
Wait, 40.
I mean, I got contact line.
But this is estimate, so basically,
Yeah.
Yeah. Idiot.
wait, now we have to interpret it. Next Gallus.
Like 60.
So what you think?
Compare it to like the graph. Oh,
Don't think we're gonna discuss it.
I think that's like
67.5.
No.
Well, we have to interpret it.
Oh, okay.
Next Gallus is covered at 45 to 55.
Why do you say 80th
Oh, we haven't
percentile?
checked on this.
Now, do you notice that's 66 to 70, right?
60%.
But she is, but like, let me point this out right
Like down to
here.
45th
Where is
percentile.
she?
Yes.
Wait, so did you
She
say like
is, how tall again?
68
Oh,
inches?
We said, yeah, I said 68.
66 inches, so like right here.
Well, what do you say?
60%.
Maybe a little bit further right.
Oh, wait,
So like, if I'm using this graph, do you really still think 80th percentile?
So like
Interpret
So
it?
maybe 30,
The one
30th percentile?
60 inches tall, 60
Yeah.
inches tall.
I said
Okay.
60.
Oh, okay.
So you're gonna
I'm
use
actually
that
5'8".
graph and use that graph to estimate.
So 65
You don't have to
is.
do that.
24, 26.
You are so kind and uplifting. I'm sure
So
people
I think it's like
love
26, 27,
talking
right?
with you.
Wait,
Thanks
this
for
is,
reading.
this half the table.
Fully it for the little line. Yeah, it looks like sort of.
Oh, yeah.
I hate you, I hate you all.
Look at Griffin's paper from the Rocket City Math.
He wrote on my paper that I should kill myself.
All right.
I'm a wrestler.
So, how did we end up deciding her cumulative relative frequency?
I just drew a line.
Just drew a line. So like we go to 66 roughly, draw it up. I think I saw 40th percentile. I heard 30th percentile.
I said 30.
Yeah, I was right.
Okay, that's where I would probably go, right around 38 or so. And you know what? Anywhere from 30 to 40 is fine because it's not super accurate. As Peter, I think as Peter had mentioned earlier, there's not any grid system here, right?
Yeah.
We'll have grid systems when it needs to be more precise. Now, so what percent are at or below her score?
40.
Let's go with that 40%. Now, so it's 40% is below, or so 40% of her stat students.
Would you not say about 40%?
How do you know if there's, wait, what did you come over
You
here?
can say about. So approximately 40% of stat students are what?
At or below her height?
Are at
Or below.
or below. So now here's the thing, that's kind of like good for a score maybe, but like what are we talking about? We're talking about her height, right? So maybe we rephrase that for her height of 66 inches or what?
Below
Or, talk about height, guys.
6 foot one?
Shorter.
Or shorter, thank you.
Okay.
Okay,
I
so
know about shorter.
they are her height or shorter. You can say at or below her score, but it's not really a score, it's a height. So let's keep that in mind. So what are we going to call that 40% though? A few of us already said it. I know y'all talked about it pretty heavily. This is the 40th percentile. All right. Whoops. So estimate and interpret the height that has a 60% cumulative relative frequency, also called a 60th what?
Percentile.
Percentile. So what would that height be approximately?
68 inches.
Yeah, I'm going with 68.
W. Which is a 69.
So approximately 68 inches tall. Okay, what questions do we have about the concept of a percentile up to this point? Once. Not twice.
Can we do an ASMR class?
Can we what?
ASMR class, just like whisper.
ASMR.
No.
Yeah,
So, I want you to work on these two check your understandings at vertical surfaces. I'm going to give y'all, let's say 10 minutes to get these two sets of problems done max. Let's try to keep it under that so we can get to the next part of this. Yes. Hey, does anybody besides Serena want the empirical rule practice? So raise your hand. All right.
Why didn't you eat pepper jack cheese, salami, and...
That's mozzarella.
That's very non-convenient.
Ms. Kowalski, can you stop the camera and then can one of y'all run and make copies of something real quick? Yeah, it would be equal to 8,000? 60%. So remember, because it's going to come back up, I'm going to talk about this in a second. So 60%, right? So 60% is lower, so what's upper? Or what's above that? 40%, right? The total has to be 100%. So what percentile is a public college with a tuition of $8,000? 60 is percentile, right? Okay, so 60th percentile there. What's Q1 here?
6,000.
So remember, when we say Q1, what percent is at or below?
25.
What percent's at or below? 25th percentile, right? 25% at or below. So because it's cumulative, cumulative is always that or below, right? Like the whole idea of cumulative, it's that or below. So I go to my 25% roughly, and so what's that tuition? $6,000. Q3, what percentile is that?
$10,000.
Oh, listen to the question.
75.
What percent? 75, thank you. Which comes out to be what, Jaden?
$10,000.
$10,000. So
You're gonna make him
Q3
crash out.
is $10,000. And then the IQR, to be careful. Nate, what is IQR?
Q3 minus Q1.
Q3 minus Q1. Right, we want upper minus lower, maximum minus minimum, okay? So my IQR here was $4,000.
Wow.
Good with that? All right. Now we are moving on to the next lesson from Mathematic. Did I not mark anything? Oh, this lesson is not going to look at this foundation bit at all. We've already done all of the foundation from this proficiency scale. We're now going to learn what a z-score is. Hear me very clearly on this. The z-score will show up throughout almost the entire rest of this course. You got to know what a z-score is, so make sure you learn it well here. We're going to look at calculating and interpreting standardized scores and using percentiles and z-scores to compare relative positions of points within data set, etc. Woo! So this should look familiar. What I want you to do, so first off, please tell me we get the reference. How did Marty do on his test? We got Biff, we got Marty. What is this?
Oh, I've never seen that movie.
Back to the future.
Thank you, Back to the Future, okay? If you have not seen Back to the Future, you need to go watch it because it's fantastic.
I want to see your reaction.
It hurts my soul, that's
I
why.
know.
Have you seen where they made like the actual cars?
Huh?
Have you seen like the actual cars they made based off of
The
it?
DeLorean?
Yeah.
No, that was an actual car.
No, I mean like people like put like what was the thing, the center console?
Oh my god.
Oh, I know. Yeah, I got
people
you.
like
The
make
flux
Yeah,
capacitor
flux
that's in the back.
put that-
Yeah, I got you now. All right, anyway, so here's what I want you to do. I want you to answer these 4 questions. Work within your small groups. Let's go ahead and do them at vertical surfaces. This will be more fun.
I'm fucking up again.
Well, our vertical
Get up, move around.
surface-
Let's answer these 4 questions.
I have a question.
I don't have it to the.
I promise.
What?
Here's the data.
Now it's the
Now,
way
grab the
we
top
do
part.
it. The progress.
The vertical surface.
I set it so you can do it late. I'll go back and look.
No, but it's like I have to help now.
Oh my god.
No, you erased this.
The lockout raster? I thought we got rid of that.
Draw the thing.
Okay, write that note over right there.
The little shape, because if I do it and I mess up once, I can see.
So let's look at this really quickly. Biff scored a 65. What's his percentile? 15. Why is it 15?
Because it's 15 points.
Three over 20.
Yep, there are 3 that are at his score or below, so 3 out of 20, 15%, 15th percentile. And so do notice, because a lot of us made a note of below here. I talked about this with one group. We can come back to this below idea in a second, but how many points was he below?
15.
15 points below. And then, so how many standard deviations did that come out to be?
Negative 1.5.
Well, hold on to that idea for a second. Just how many standard deviations? 1.5. And I talked about this with most groups, okay? Now, I need to emphasize this. And I love the way that Serena described it over there. I wrote it in blue. How did Serena end up describing how to determine the number of standard deviations? It's a
Distance
fraction.
from mean over.
So we talked about the fact that it's the distance from the mean.
No, I did.
I was there, Serena said it. Distance from mean
I did the actual word.
divided by
Standard deviation.
standard deviation. Okay? So if I take how far something is, and I divide it by whatever the standard deviation is, that's how many standard deviations there are, right? So hold on to that idea. It's going to come back up in a second. So Marty scored a 97. What percentile? 95th percentile. Okay? And so the 95th percentile, because there are 19 out of 20 that are less, or at or less. Now, this is where we do need to notice Marty was above or below the mean? Above the mean. By how many points? 17, right?
It's 13.
What was his score?
I got it.
Oh,
it is
Oh, wait,
17.
that's 17. That's my bad. So 17 points above the mean, and so how many standard deviations does that come out to be?
1.7.
1.7, right? We take our distance from the mean divided by 10, so 1.7 standard
If I'm
deviations.
gonna be
Now,
honest, I didn't really do the counting.
Minus 80.
here's what, and Serena already said it and hinted at, and I need y'all to hear me on this. This is 1.7 standard deviations above or below?
Above.
Above the mean, right? Whereas earlier it was, we didn't actually write it. 1.5 standard deviations below the mean. Now, one thing I will point out, typically when we abbreviate standard deviations, we don't write STD. We write st.dev dot, or SD, or you can just use S for standard deviations. Yeah, we're not talking about STDs in stats class. We can cuss all day long, but we're not talking about STDs, all right? So keep that in mind. But notice if something is below the mean, is it recording? You sure?
Or wait,
Yeah, I thought I started recording it. If it's below the mean, so that's just 1.5 standard deviations from the mean. 1.7 from the mean. So how am I going to indicate if the value is below the mean versus above it?
Negative and positive.
Negative and positive. Negative would be for when the value is below the mean. And positive when it is above the mean. So hold on to that idea, is that's how many standard deviations above or below. So use a negative when it's below the mean and a positive when it's above the mean. Questions about that? Okay? But now we want a formula. And this idea of a z-score is the number of standard deviations above or below the mean. Now, hear me very clearly on this. We are going to use z-scores very heavily with normal distributions. However, you don't have to have a normal distribution to have a z-score. All a z-score is the number of standard deviations above or below the mean. It doesn't matter if it's bimodal, it doesn't matter if it's skewed right, skewed left, it doesn't matter if there's outliers. A z-score is just the number of standard deviations from the mean, above or below the mean, technically, okay? So how are we calculating that z-score? I'm going to start with what Serena said of distance from the mean, divided by what?
STDs.
Okay, so standard deviation. But what's a symbol I could use for standard deviation?
The S bottom X.
So sigma or S. Okay, so we're going to do two. We're going to do one with sigma, one with S. All right. So how though are we calculating the distance from the mean? I want one expression that always works.
absolute value. What?
No, because you need the negative.
I do need the negative, so do I want to do absolute values? No, I want it to be able to get a positive. I want to get a negative.
So the value minus it.
So if I take a value, and I subtract the mean from it, if the mean is larger, what kind of value am I going to get? A negative. Which, if our value is below the mean, what do we want? A negative. Cool. But if the value is above the mean, then this is going to be positive. That's our z-score formula. We find how far it is from the mean and divide it by the standard deviation. Now, if I'm dealing with parameters, it's just going to be x minus b. Same exact thing. Okay? So, hold on to this because this is important. Now, one thing I do want to emphasize, because I talked about this in my Algebra 2 vid recently, but I haven't talked about it here as much. I should have with percentiles. Guys, when we interpret on the AP exam, or just interpret in life, there's two things you got to do. You got to take that number and go back to the definition of what the thing is and put it in context. So when I talk about this z-score right here, what do we mean by z-score?
This is for mean above standard deviation.
Well, not just standard deviations, the number of standard deviations either above or below the mean. So I want you guys to now look at number 6, use this information. Goldie scored a 93 on the Unit 1 test. Find and interpret that z-score. Let's go. Great question.
You know what? Good
Guy,
guys.
the peoples at the chalkboard that Jaden got kicked off of did. But Goldie's test score of 93, right? Notice we start with the context of that score, and then we go into the standard deviations. It is 1.3 standard deviations. How do we know it was above the mean?
It's positive.
It's positive, and quite literally 93 is above 80, right? So it is 1.3 standard deviations above. Now I talked about this with Michael. The one thing I would say, and this is the same thing y'all had an issue with, is y'all tried to put that mean at the end after putting the word mean and then context. A simple switch here that makes it more efficient and less clunky at times is just say above the classes mean score of 80. Notice that reads more smoothly. Over here, we could have said Goldie's score of 93 is 1.3 standard deviations above the Unit 1 AP Stats mean, test score mean of 80, right? So notice I put that context before the word mean, and it's a mean of 80, and so that makes it flow a little bit more smoothly. Okay. All right, I want y'all to do number 7.
Relative to everybody else, relative to ourselves, relative to...
See, that's an important question we need to understand, because what does a z-score measure?
Relative to them.
Relative to others. Yes, how many standard deviations, quite literally. But so what's a z-score doing? What's a percentile doing? It's measuring your score in comparison to others. So in comparison to others on this test, which test did Lorraine do better on?
Depends on what the mean
Psychology.
was.
Wait, what?
It doesn't depend on what the mean was. Look, in comparison to other people on the test, which test did she do better on?
Psychology.
Psychology, right?
Z-score.
She is 1.9 standard deviations above the mean.
But what if the
That's
standard
better.
deviations were different?
You mean like right here?
Look what we did.
Right. So let's come back to what you're saying in a second.
Okay.
Let me say it this way. Which test did she actually score better on? In terms of like a percentage for the test grade.
Psych. I think.
Biology.
Okay, look at yours again. You have a higher grade for bio, don't you?
Oh yeah.
So that's the thing that we need to recognize is it's important to think about like how is she doing in relation to others versus how did she just do. She did better in the bio test, and no matter what the situation is, but in relation to the rest of the class, So remember what this literally means, Serena, is that her score was 1.9 standard deviations above the average.
Okay.
Even when the standard deviation changes, she's still 1.9 standard deviations above the average, whereas here's only 1.4. So she did better on the actual test grade, but in comparison to everybody else,
But
she
what
did
if-
better on psych.
What if the like psych standard deviation was different? Like on here, say it was like
You mean the standard deviation or the z-score?
standard deviation.
Right, but when you change your standard deviation, remember, they already set it as, even if you change what the standard deviation is, wasn't it for psych still a z of 1.9?
Yes.
And the bio was still a z of 1.4? That's what's determining how she did in relation to everybody else. But then, this is her actual scores.
But
So you're right that she did better on the bio test, but in relation to everybody else.
no, that's not what I'm asking. Say like you change the bio, well, no, the psych standard deviation to 10 as well. Then she would have had a higher score on the psych test.
I see what you're saying. Here's what you gotta remember. If you change the standard deviation here to 10, the z is the only thing that you were told has to stay the same, so her grade would have to go up. But then it wouldn't satisfy the other part of this. So let me point this out. It had to be one of two things. Either the mean on the bio test had to be higher and standard deviation the same. Or the standard deviation on the biology test had to be higher and the mean stays the same. So that we keep these z-scores.
Okay.
Remember, they said the z-score had to be 1.4 and 1.9. So no matter what, in relation to everybody else, she did better on the psych test. Raw score-wise, she did better on the bio test. Okay? So, let's look at, I think this is yours tonight, isn't it?
I think that's mine.
Oh. All you people stapling your papers.
You people?
I said what I said.
Oh.
Okay.
No, wait a minute, you
No,
can't
you're
say anything
thinking
because of what you said
Friday,
earlier.
What did I say earlier?
Yeah, I'm always feeling froggy. Alright, let me check to make sure, okay, it is recording. Alright.
So make sure that was on record.
So here's a set of check your understanding. What I need you to do is,
What's the time? I said what I said.
What time is it?
tonight, I need you to do these 4 check your understanding questions.
What do you mean tonight?
Okay? We're gonna go over them tomorrow, so y'all gonna be here
Oh,
tomorrow,
we're just
right?
307?
Yeah.
No.
You're not gonna be here
No.
tomorrow?
Two
Most of
days?
this class is not.
No. I'm
Where
gonna
are
be
you
here.
gonna be? There's only 3 of them.
She's
Oh,
going
that's
to
one
the
goal of the
show.
class.
Yeah,
That's
well,
not most.
okay, just another third leave. That'd be 3.
And I will
Hey, come to
still
the show,
teach,
come to the show, come to the show.
and I will,
Come to the show.
Hey, listen, we got an AP class, I know that a lot of us have to be gone for that because we're literally in it. Otherwise, I would just come after school, like where I'm planning on doing either Friday or Saturday.
We have a
okay?
show after school too.
Huh?
We have a show after school Friday.
I
Yeah.
know, that's why I'm coming either Friday
Like
or
the
Saturday
kids
after
were
school. Not going during 4th block because I got an AP stats class to teach.
Oh, you
No, I think the whole class
Field
should
trip.
just go and support them.
Oh, you
And once again, I will still teach and I will upload that video,
You're
and
gonna teach
it'll
it in
probably
the
go
middle of the
quicker
show.
because I'll have some people all the time.
It's just the show's going on in the back.
So-
just like standard deviation, standard deviation.
He gets up there.
Alright, this is what we are heavily focused on with this section, is we're gonna get further into the idea of empirical rules, standardized z-scores, all the fun stuff. So, we're actually gonna skip to the next lesson. We're gonna talk here, actually, so this is gonna help us with some of the normal distribution stuff. This is gonna bring up an issue with the empirical rules. So hear me again on this. The whole point of this, I'm jumping ahead in the mathematic lessons, is to bring up an issue with the empirical rule that I want us to see, and then we're gonna go back to an earlier lesson that they have. So, turn to this. Remember, I need you to do the check your understanding tonight, but I need you to turn to this lesson that says, how long is your favorite song? Yes, it had Taylor Swift and Ed Sheeran. If you're not a fan, cool, that's fine. What I need you to do is I need you to do 1, 2, 3, 4, and 5. And we need to at least be able to talk about 5 before the very end of class, so we're quickly and efficiently.
Can I go early to Miss Faraby's class because I forgot my light in there and I needed to.
Songs that are shorter than 181 seconds.
That's such a weird spot.
Why do you say that's in such a weird spot?
Oh, you, z-score.
It's not one of our what? One of those
Z-score.
standard deviations. So
Z-score.
z-scores, I want us to think about this. 181 minus 220 divided by 26. What is that? Negative 39 divided by 26 is negative 1.5. So right in between here. And I want what's less than that. So how am I going to find that percent?
Oh,
You just count one.
like,
So here's what I need y'all to hear me on, so we're going to end today. I was able to do halves earlier because there's symmetry. This side is the same as this side. Is this piece the same as this piece?
No.
So when you do not have an integer number of standard deviations, you cannot use the empirical rule. That's why we need z-scores. When you do not have an integer number of standard deviations, you cannot use the empirical rule. Hey, please take a calculator to help you do the homework.
What's up? I really
See ya.
did.
Hey, Jaden, are you going to be able to